Hey guys, so for this video I decided to show you what to do if you want to interface a PS2 wireless controller, or any PS2 controller really. They all have the same protocol. It uses SPI, serial peripheral interface, to communicate between the controller and the PS2 console, which we're going to use a PIC16F690 to act like that. On a 20 megs crystal, and I programmed that in assembly. The main reason was because the PIC16F architecture, they say, is not well suited for the C language, so there's not too many compiler options out there, especially unless you want to use micro C. Micro C is a compiler for most of them, but if you want to stick to MPLab, you might have to do it in assembly. So I decided to do it in assembly, and it's good to know assembly anyway. So if you guys want to get started with that, PICs is pretty simple. So I'll throw that up on the video when I upload it. It's pretty small just because I'm only showing what the controller is doing on the scope. So you're going to see voltage lines go high and low on the scope instead of actually reading it back on the microcontroller. But yeah, for this I actually hooked up my scope to the PS2 console that I have using this other PS2 controller that I have, and started observing what was coming in and out on each line or on each pin, and eventually, after some time and frustration, figured out it's SPI. I wish I saw this site beforehand. I'm going to show it to you guys so you guys don't have to go through all this, but this site tells you almost everything you need to know about how to interface a PS2 controller, even these pinouts. I did use it for this. This is how the byte structure is going to be. Yeah. So you send a 0, 1, 4, 2, 0, 0, 0, 0, 0, 0. The last two, that 4, 5 byte, those are going to be for reading what the controller says. So the first three you send out, the controller is going to send back the same thing every time. The next 2 bytes, whatever the controller sends back on 4 or 5, on the 4th or 5th byte, depends on what button you pressed. So if you pressed up, you should expect one of the bits of byte 4 to go low. If you pressed X, you should expect one of the bits of byte 5 to go low that you're getting back on the serial data inline. I'll show that to you right now. So you can see, here's one example. This is byte 4. You can see that's the clock on the top. The bottom is what the PS2 is sending back to the microcontroller. You can see it went low on one bit of that byte. I'll show it to you in action. So here we go. It's running. It's a little jumpy, but I'm pressing down now, or I'm pressing down. It's jumping because it keeps switching between byte 4 and 5 on the scope, but it's okay. You can see it's going low every time I press it, and if I press left, it's shifting a little, going right, shifting a little, going up, shifting a little, so it's changing each bit of the byte sending back. And if I want to press X, maybe I can see it. Yeah, X is going to show too because it's showing both of them on the scope. But I'm going to zoom out a little. Let's see. I'm going to pause it. Yeah, so here's an example of the 5 bytes. So that's byte 1. You send the 0, 1. Make sure you know that the PS2 is LSB first, and the PIC SSP module might send the MSB first, so you might have to write an 8-0 on that first byte on the serial data outline in order for the PS2 to register. Next one's the 4-2, you get a 4-1 back. Next one's 0-0, you get a 5A back, and these are the 2 that you're going to read depending on what you press on the controller. So I'm going to press X right now, and then stop it. See? So it just changed. You could see that before that line was high, and now it dropped on one of the. I stopped it too early or too far out, but you can see it dropped instead of being high because I pressed a button. So yeah, that's the idea of it. It's pretty cool. You can use this for almost anything wireless you want to put in. It's cheap. It's only $20. Any kind of wireless remote control that you want. Throw this up on the code up on the channel here. And also, if you guys want to learn a bit more about SPI, this SparkFun article is really useful serial peripheral interface. If you don't know about it, you should. It's a pretty common protocol to use. Yeah, and it's much faster than UART if you're still using UART for a lot of your projects. If you have any comments or questions, don't hesitate to leave them in the comment section. I'll try and answer them if I can. Alright, thanks for watching.